As we all know by now, LLMs can be very unreliable. And this is the biggest problem building with AI models, building features or agents, that they aren't consistent, that you can't get it to, repeat with in a deterministic way. And in this demo, I want to exemplify this problem and show you a little bit on how Opper solves this. So what we're looking at here is a classical chat app, just like ChatGPT, with the only difference that you can interact with multiple models at the same time. So we're going to use this in order to show a couple of problems, but also then move on to show how Opper can solve some of these problems. So one of the simplest examples of showing unreliability of models is a simple message like hello. Now we're interacting with 3 models at the same time, all through the Opper AI platform. But what you can see here is that we have Opper off here, meaning Opper is not doing any kind of intervention. We're interacting directly with the models, essentially. And what we can see here is that we're sending exactly the same input tokens to 3 models at the same time. We're using this very small 20 billion parameter model, GPT-OS, an open weight model. We have Opus 4.5, arguably the strongest models, and we have Grok fast reasoning, which is a contender to be fast and relatively fast and smart and cheap. So what we can see here from the get-go is that these 3 models respond to exactly the same input tokens in different ways. So the first example here is that you cannot typically just switch a model because it will, trigger different behavior. So there's no transition between an expensive model to a cheap model, for instance. The other problem is that if I send hello again, what we will notice is that these models will also, change its response to exactly the same input tokens. So here we have history off, meaning this is a completely new interaction with these models. And we can see from Opus here, for instance, that it's choosing to respond differently, even though the input tokens are exactly the same. So this means that even with the same model, we will have unpredictable outputs, non-deterministic outputs, which makes it very hard to understand completely what the model will do in a scenario like this, a chat app, but also with agents and similar. And what Opper does here is that we can turn on Opper on here, which means that we are engaging the Opper platform to re-engineer how we are interacting on a low level with these models. We don't change anything about our application as such. We just allow Opper to engineer the context, engineer the input tokens we're sending to the models to make it more reliable and more repeatable. So let's say I want to have more responses in the style of this Grok 4 fast reasoning. The Opper platform supports sending feedback to the platform so that it can ground the responses we want from these models based on end user feedback or other things. So what we now do with Opper on is that we can do the same message, we send a hello. And what we'll notice is that it's now much more aligned towards what we voted to be an appropriate response. And what's interesting with this is that we can also see how this generalizes. So if we change the way we interact with the model, we will still get similar consistency. We can even change language, and it generalizes across languages. We can continue voting. And through this means we can get models to be reliable by grounding it and re-engineer the way we're interacting with the models. So here we're looking at a simple use case, a simple message in a very common form factor like chat. But what's important to remember here is that this process that these models are doing under the hood called next token prediction applies equally well for other use cases as well. So for instance, in agent use cases, you might be tasking a model to choose a tool to use. So similar, inconsistencies will arrive for things like tool calling. And the same process of voting, of creating ground truth of what we actually want, the behavior we want the models to repeat, can be applied to other kinds of use cases like agents. So Opper is a very general way to inject reliability into basically any agentic or AI feature in this simple manner, like thumbs ups and thumbs down. But you can also invoke this feedback in other ways, programmatically, etc. This is the biggest barrier of AI making it from demos and kind of human-assisted features to autonomous agents, where reliability needs to get close to this 99.99% that we're expecting from software in other domains. Thank you.